Hi, welcome back. In this section, we're going to look at part of the section 8.2 in our text. And the very first part of that section deals with the products of powers of sines and cosines. And here's one example. You might have something like sine to the mth x, cosine to the nth x dx. And in this particular part of even this section, there are going to be three different types of problems. And the first one I want to work with you is one where m is odd and n can be anything. And when I say anything, it doesn't, some students at the beginning think it needs to be an integer, but it doesn't. It could be like the square root of x, in which case n would be equal to 1/2. Or n could even be equal to 0, in which time I wouldn't have any cosine because anything to the 0 power is 1. So the only requirement here is that m needs to be odd. Okay? Essentially, the technique we're going to use is to factor out one of the sine factors. Now remember, if m is odd and we factor out a sine factor, then we will be left with the sine to an even power. And then after that, we're going to use the identity sine squared plus cosine squared equal 1. Now stay with me, and I'm going to be working an example. All right, here you go. I have sine cubed x cosine squared x. Notice m is odd, n is even in this case, but n could be anything. Now when I follow my directions that I just mentioned, I factor out a sine. Here it is, sine x, and then I'm left with an even power of sine squared. So notice, sine squared x times sine x would give me my sine cubed x at the top. Then I use the identity that sine squared plus cosine squared is 1, and I replace sine squared by 1 minus cosine squared. All right, now I'm going to use the distributive law, and that's the next equation you're going to see. Okay? I took 1 times cosine squared times sine, and that gave me cosine squared times sine. Then I took cosine squared times sine, and that gave me cosine to the 4th x times sine of x. I hope you can see the x here. When I typed this up, I forgot the x. Notice I broke it up into two integrals, which I'm certainly allowed to do. Now, the reason this technique always works, everybody, is because now I have cosine to a power times sine, and this integral and this integral are both of the form u to the n du. Let's go to the next sheet. All right. So now what I'm doing here is I'm showing you the work to put this into the form u to the n du. If I let u equal the cosine, you know the derivative of the cosine is minus the sine. So I put my -1 here. And if I put 1 to the right of the integral sign, I need to put 1 out in front so I don't change the problem. -1 times -1 is +1. And then I do the same thing over here. Remember, this minus sign right here is from the previous page. But then if I let u equal cosine, the derivative of the cosine is minus the sine. So I put my -1 here, and then I need another -1 out in front. Now taking all of these negative numbers into consideration, all right, and then using u to the n du as my antiderivative formula, I have minus. I increase the exponent on the cosine by 1 and put the same thing in the denominator. Here I have minus is plus. And once again, I increase the exponent by 1, makes it a 5, and I put the same thing in the denominator. So now that takes, that's the first example of where you have powers of sines and cosines, and the exponent on the sine is odd. Some other problems, like I said, that fit into this category would be sine to the 5th cosine squared. Notice this is odd. Sine to the 7th x. Notice I don't have a cosine, but that would be the case where the exponent on the cosine would be 0. And yet here's another example that I'd like to show you, and that is sine cubed x cosine to the 1/2 x. All right, I'm going to quit this video now because otherwise I'm exceeding my limit of 10 minutes. So I'm going to say goodbye, but please try to take your time to look at the next video that follows this in succession, because it's really a continuation of the powers of sines and cosines. Okay, bye-bye. See you in a minute or two.